Hello, we are ASC Engineering. On this presentation, we will present our design for the State Route 67/Highland Valley Road roundabout. My name is Christopher Ramos, and I am the project manager for this project. On the following slides, I will present the project overview and the ASC Engineering team. The objective of this project, as stated in the request for proposal, is to improve safety and traffic flow for the intersection of State Route 67 and Highland Valley Road by designing and constructing a roundabout. The ASCE engineering team consists of, from left to right, Christopher Ramos, acting as the environmental engineer, Dwight Ashman, acting as the geotechnical engineer, Richard Moreno, acting as a traffic engineer, Joe Berhumi, acting as a transportation engineer, Jason Bell, hydraulics and hydrology, Sean Mosh, cost analysis.
The State Route 67 and Highland Valley Road intersection is located approximately 20 miles northeast of San Diego. This intersection serves as the main arterial passage which connects the unincorporated communities of Ramona and Julian to the greater San Diego area. Every day, over 2,500 vehicles arrive at these intersections during the peak traffic hour, creating traffic that extends for miles on each connecting corridor. The source of this delay stems from the intersection's inadequate number of lanes, the volume of traffic, and the traffic signal located at the intersection itself. During low traffic hours, speeding drivers often misjudge the stopping distance required for the vehicles to come to a complete stop. This mistake leads to catastrophic vehicular accidents. These traffic delays have a significant impact on the environment by means of CO2 emissions, the driving mood of motorists by provoking aggressive driving, the economy of the city, and the everyday life of the Ramona community. In order to address these problems, ASC Engineering has developed and designed a roundabout intersection solution. This design will help to reduce the number and severity of accidents, reduce the roadway delays, reduce CO2 emission, and promote economic and community growth.
Our design goals here at ASC Engineering for our roundabout are to ease the flow of traffic, as well as improve the level of service at the intersection of State Route 67 and Highland Valley Road. Our roundabout will improve the queuing, as well as lower the incoming speed at the intersection. We at ASC Engineering chose to adhere to the highway design and highway capacity standards. We based our design off of the NCHRP, National Cooperative Research Program. We designed a multi-lane roundabout that consisted of 2 lanes. These lanes are 16 feet wide so that a 67-foot truck can travel through the roundabout safely. The proposed roundabout will have a diameter of 160 feet. The roundabout is designed for a speed of 25 miles per hour. This design will lower the current speed of the State Route 67 highway from 55 miles per hour to 25 miles per hour. We calculated that this design would be able to lower our level of service from a grade F to a grade D. We calculated that our design will be able to continue to provide a better flow of traffic for the next 20 years. Our approach at ASC Engineering will have a limited impact on the surrounding environment, as well as improve the flow of traffic at the intersection. We will also provide a safer speed and reduce the number of crashes at the intersection. We at ASC Engineering believe that our design meets all the criteria we set out to accomplish at the beginning of our proposal.
The project site is primarily comprised of alluvial deposits containing well-rounded boulders, gravels, sands, and silts. The unified soil classification for these deposits are primarily silty gravel and silty sand. These are both non-cohesive soils and as such are highly susceptible to erosion, making stormwater management important for the success of this project. The R value for this project was obtained from recent examination of the site with an R value range of 20 to 45, which is typical of gravels and sands. An R value of 20 was taken as recommended from the California Highway Design Manual based on the lowest R value present. The subject site is flat with no proposed slopes or structures, and minimal grading will be required. The soil at the site is adequate in both strength and expansion characteristics for the proposed roundabout. No conditions or structures were identified at the site that would cause any engineering challenges to the proposed project. Pavement design recommendations are based on the California Highway Design Manual, using a traffic index of 6 based on projected traffic characteristics. These values are minimums and may be increased as deemed necessary by the transportation engineer. The subgrade should consist of compacted native soil with the R value taken to be 20 for this project. Overlaying the subgrade is the number 2 subbase. This layer should be 4.5 inches thick with a compacted R value of 50. The number 2 aggregate base should be a minimum thickness of 5.9 inches with a compacted R value of 78. The surface layer should consist of compacted asphalt concrete with a binder graded PG 6410, and it should be at 3.5 inches minimum thickness. These values were obtained based on the manual method from the California Highway Design Manual and should be used or exceeded in all pavement design for this project. Thank you.
For the hydrology, I broke up the areas into 4 quadrants: northeast, northwest, southeast, and southwest. The arrows indicate the rainfall flow pattern, as you can see on the site plan. The water naturally flows from the southwest quadrant to the northwest quadrant and then to the northeast quadrant. Also, the southeast quadrant flows to the northeast quadrant, where the water collectively drains off-site. For the drainage analysis, I used the 100-year event to design the drainage system. 24-inch drainage pipes will be required to handle the peak runoff flow for this 100-year event. The circles on the site plan represent these drainage pipes.
According to the California Environmental Quality Act, which requires that local government agencies, prior to taking action on projects over which they have discretionary approval authority, consider the environmental consequences of such project. Some potential areas of concern that are associated with this project are air quality, greenhouse gases, noise, traffic, and water quality. Due to the current condition of the site, it is not suitable habitat for any species. With mitigation, the overall impacts of these areas will be considered less than significant. Overall, the project itself will improve traffic efficiency and minimize vehicle wait times, therefore reducing most of the environmental impacts.
There are a lot of factors that influence the amount of economic investment justified for any type of project. The benefits of a roundabout are worth the investment. Some of these benefits may include reduced crash rates and severity of crashes. Also, roundabouts reduce delay, fuel consumption, and emissions. All these benefits weigh heavily in the decision to invest in a roundabout. Higher costs are typically incurred when a substantial amount of realignment, grading, or drainage work is required. The cost of maintaining traffic during construction tends to be relatively high. This expense is due mainly to the measures required to maintain existing traffic flow through the intersection while rebuilding it in stages. Other factors contributing to high roundabout costs are large amounts of landscaping in the central and splitter islands, extensive signing and lighting, and the provision of curbs on all outside pavement edges. Right-of-way costs are approximately $500,000. This includes the acquisition of a small percentage of 2 parcels located at the east and west corners of the existing intersection. We are expecting existing utilities such as SDG&E, Cox Cable, AT&T, and the Ramona Municipal Water District to be at a depth as to not interfere with the new roundabout. The construction estimate for this roundabout is approximately $1.6 million. These costs have been calculated using the current design set forth in the design section of our submittal as a guideline. The total cost of this entire project is $2.1 million.
Lastly, we want to thank you for taking the time and listening to our project, and that we really appreciate your business. Thank you.